Hello, and welcome to Relational Database Design, Data Modeling for Beginners, Part 1 of 2. My name is Tim Jones from Accelerate Computer Training in Long Beach, California. In this two-part video series, we're going to teach you the skills and strategies used to plan the structure of new relational database systems. The emphasis here is on structure, what the database will contain, not interface or what it will look like. Our target audience for this session is the non-technical user who needs to track related sets of information but wishes to improve their understanding of relational database architecture. On the agenda for these two sessions, we will define and defend the need for relational databases, learn the skills needed to plan a database, including how to identify entities and attributes in a real-world scenario, identify relationships between entities and determine their cardinality or type of relationship, and draw an entity relationship diagram or ERD that clearly illustrates the plan for a proposed database. We'll also discuss the role that key fields, both primary and foreign keys, play in relational databases. We will not build any databases because how you create tables, fields, and relationships will depend on the database development platform you choose. Whether you build in Airtable, FileMaker, MySQL, or another platform, you need to construct a plan before you start to build. Can you imagine a construction crew showing up on the job site without a blueprint to follow? How would they know where to dig, where to cut, how much to pour? As the saying goes, if you fail to plan, you plan to fail. So we're going to learn how to plan a relational database. But before we start that, there are some terms and definitions we all need to understand, starting with relational database. A relational database, called simply a base in Airtable and a solution or app in FileMaker, is a collection of related data about entities, organized into separate tables. What's a table? A table is the structure in which data describing an entity is stored. It's made of columns and rows like a spreadsheet. Each column is a field and each row is a record. An entity is a thing or idea about which we want to store data. As an example, a table storing data about the entity classical music compositions might be structured like this. Note that in a relational database system, we create one table per entity. Why not just store everything in one big list, you might ask? Why use multiple tables? I'm so glad you asked. We use multiple tables to avoid inconsistent data entry and to eliminate redundant data entry and storage. Let's look at our classical music compositions table again, this time with only records of some of Bach's compositions. Notice the inconsistent data entry. In the composer field, we have 3 different renditions of his name, which to a database looks like 3 different composers. In the era field, we have 2 different entries for the classical era. There were obviously no restrictions on what users were allowed to enter in these fields, and as a result, we get inconsistency, which will cause trouble when we try to search or report on this data. And not only are we asking our users to type the same data values over and over, which eventually leads to inconsistency, but we're also asking the database to store those values repeatedly, which makes the database big and slow. If only there was a way to store an entry once and reference it many times, well, there is, using multiple tables in a relational database. Splitting entities out into separate tables for composer, era, and style lets us enter and store each value only once, which guarantees consistency. How many times would we enter Mozart's name in a system structured like this? Only once. Likewise, each era and each style is entered and stored only once in its own table. We use a primary key field, called ID here, to automatically assign a unique identifier, like 1, 2, or 3, to each record when it's created. Then, in the composition table, we'll enter a composer's ID number instead of their name, like a 1 for Mozart, a 2 for Bach, and so on. Likewise, we enter an era ID number instead of typing the era name, and a style ID instead of typing the style name like fugue or concerto. It eliminates typing and storing long text entries, which always lead to inconsistent data, and it also resolves the dilemma of two composers, for example, having the same name. Unlikely, you say? Did you know that there were two famous classical composers, both named Johann Sebastian Bach? Take it from a guy named Tim Jones, names are not guaranteed to be unique. Now, I know you're probably thinking that this will never work for you, because you couldn't bear to see numbers in place of the actual composer's name or era or style or whatever. Don't worry. A well-designed database would never make users view the data like this. You would see the composer's name referenced from the composer table where it lives. It's the ID numbers that are the key to relating records of data to each other, which lets us view that data anywhere we want. If I've convinced you that the multi-table structure of a relational database system is reasonable and prudent, let's learn how to plan them. The skills I'm about to teach you are generally referred to as data modeling, which is the process of turning real-world scenarios into sound data structures. When we talk about database development, there are often two sets of terms we use during the different phases of development: virtual phase and physical phase. During the virtual or planning stage, we call each thing we're going to track an entity. But when we start to build the database, we'll create a table for each entity. Similarly, while in the virtual or planning stage, we call each characteristic of an entity an attribute, knowing that each attribute will become a field in the actual table. And lastly, we might talk of an instance of an entity being the same as a record of data in a table. Having defined our terms, we're ready to begin planning. You should always start with a process description. This is a written statement describing the proposed database. It could be as simple as, we want to store information about the classical compositions in our collection, including title, composer, era, year, and style or genre. Try to involve as many of your stakeholders as you can when drafting the process description, and get agreement from them on what needs the database must address. This gives you a goal, a finish line to cross, even if only for phase 1 of the database. Once the process description is ready, we can identify entities and attributes. I call this going on a hunt for nouns, because the nouns in the process description are usually entities, attributes, or both. You'll recall from earlier that an entity is a thing or idea about which we want to store data. An attribute is a characteristic or descriptor of each entity or of an entity. Now, for each noun, here's how to tell the difference. An entity has multiple attributes that describe it, while an attribute is only one value. Let's practice. Here again is our process description, our real-world scenario. Let's list the nouns, the relevant nouns, as we read it. We want to store information. Information is a noun, but not relevant to the database. About the classical compositions in our collection, including title, composer, era, year, and style or genre. Okay, we got them all. Now, let's figure out whether each one is an entity, a thing or idea about which we want to store data, or an attribute, a characteristic or descriptor of an entity. To determine the difference, remember, an entity has multiple attributes that describe it, while an attribute is only one value. Some nouns may be both an entity and an attribute of another entity, so keep that in mind. First up is composition. When you think about a specific classical music composition, like Beethoven's Fifth Symphony, for example, are there multiple attributes that come to mind that describe it, or just one value? There are multiple data values that describe a composition: its title, its composer, the year it was written, etc. Therefore, composition is an entity and will deserve its own table in the database. We create a box for each entity. These boxes will ultimately become our entity relationship diagram, our blueprint for the database. Earlier, we learned the value of automatically assigning a unique identifier to each instance of an entity, so we will add ID as the first attribute of each entity. Okay, one down. Let's move on to collection. This word appeared in the process description, so we added it to our list of nouns or potential entities, but the term collection could refer either to a specific person's music collection or the entire body of work that we call classical music, and it would not affect the structure of our database. So we can scratch that one off the list. Next is title. When you think about the title of a composition, are there multiple attributes that come to mind or just one value? A title is a series of words, yes, but it makes up one single value, so title is an attribute. Which entity does it describe? A composition, of course. So we add title as an attribute to the composition entity and mark it as managed on the list. Next up, composer. Does composer bring to mind multiple attributes that describe it? Certainly. A composer has a first name, a last name, a birthplace, and many other interesting characteristics. That means composer is an entity, so we make a box for it and list its attributes. But composer, while being an entity itself, is also an attribute of composition. We track that by adding composer ID under composition. And now we can mark it off the list. If you're wondering, how are my users going to know the unique ID number of the composer who wrote Piano Sonata No. 2 in B-flat minor? Don't worry. Every database platform provides a means of entering an ID number by choosing from a drop-down menu or pick list that shows the name or title of the thing. Next, we have era. Music historians have divided classical music into three eras: Baroque, Classical, and Romantic. They actually use these eras to describe composers, not compositions. For example, Bach lived during the Baroque era. Thus, every one of his compositions was a Baroque composition because he was a Baroque era composer. So era is an attribute of composer, not composition. By the guidelines we've used so far, era would seem like an attribute. For any given composer, we would need to store only one value to describe their era. However, there is something else to consider. We do not want to force or even allow users to enter the same values over and over in the same field across many records. It leads to inconsistent data entry and makes the database big and slow. We need to optimize or normalize this attribute by giving it its own table where we will create a record for the three eras, each with its own ID number and title. And then we will define an era ID attribute in the composer entity. We've dealt with era. Now, I know this is detailed work, but stay with me. You're going to have to do this on your own soon. Only two more. Year written. Is it an entity or an attribute? Are there multiple attributes that describe the idea of the year when a composition was written? No, it's a simple attribute of a composition that users will type freeform into a year field. Lastly, style. It is obviously an attribute of composition, where we will enter whether a piece of music was an opera, a concerto, a symphony, etc. But there are only so many distinct entries we would ever make in this field, so to avoid inconsistent entries, and with the goal of normalizing our data, we should create a separate style table with at least these two attributes, ID and title. In the composition entity, we need a style ID attribute where we will implement a drop-down menu fed by the records in the style table to help users enter the ID number that identifies the style of each composition. There, we've accounted for all the nouns in the process description. And now it's your turn. Here is a new process description. Read it and write down every potential entity you see. I recommend phrasing entity names in the singular rather than the plural form, as in person rather than people. Okay, go hunt for those nouns. You have 1 minute, or for as long as you want to pause the video. Now, let's go through it together. The first relevant noun is child or student. The next one is class. Now, did anyone write down year as a potential entity? I would agree with that, but for the last sentence, which says we do not need to track year-over-year history of each student, but rather only a snapshot of where each student is right now. After that, we come to teacher, and then behavioral incidents. If you think we should just store incident data in an open-ended notes field, we'll get more control by storing it in a separate table. Next, to notify the parents, we'll need to store parent or family contact details. Next, there are several classrooms, so that may be an entity. And then pre-K and kindergarten, which are grades. The last two sentences do not introduce any nouns that are not already on the list, so now we move on to inspecting our candidate entities more closely to determine which are entities, which are attributes, and which may be neither. The first potential entity is child or student. It is definitely an entity because there are many attributes that describe it. But should we call it child or student? Well, there's often more than one word that could be used for the same noun, so this is the time to decide what you want to call each entity. Eliminate all synonyms and choose entity names your whole team will understand and adopt. Let's go with student. Each student will need an ID, but what other attributes describe a student? First name, last name, date of birth? Good. How are we going to keep track of which class a student is in? Well, class is next on our list to consider. Is class an entity? Yes, a class has several attributes that describe it. An ID, a title like Miss Johnson's pre-K class. And although that title makes clear both the teacher and the grade of that class, it would still be wise to store both the ID number of the teacher who teaches the class and the ID number of the grade of each class. I know we haven't even dealt with the teacher or grade as candidate entities yet, but we will, and we probably know already that they are entities in and of themselves, as well as being attributes of the class entity. The ID number of the room where a class is held would also be an attribute of each class. And now that we have class as an entity, we can add class ID as an attribute of student. Anything else about student? A student has a parent or family, which is on our list, so we'll add a box for family with some attributes, and then add family ID to the student entity. And now we've dealt with student, so we'll cross it off as managed. We've also managed class and parent-family, so we can move on to teacher. Are there multiple attributes about a teacher? Yes. The teacher has a first name, a last name, a date of hire, a phone number, and perhaps more. And we've already noted that teacher ID is one of the attributes of a class. Next up is incidents of good or bad behavior. I've included this not to bring up any painful memories of your own childhood misdeeds, but because I thought it would give us another vantage point from which to consider an important strategy in data modeling, that of asking yourself, how many of those could relate to one of these? Or in this case, how many incidents could any one student have? If it is many, then you should almost always make a table or entity for the many thing. There's a principle in database design. One fact, one field. That is, if you have a data value to store it in its own field. Don't store 2 facts in one field or 3 facts in one field. One fact, one field. So to keep track of these incidents, we're not going to make a notes field in the student table and just keep a running text log for each student. We're going to create an incident table, giving each incident a unique identifier value, along with the ID number of the student and the date and description of the incident. Let's move on to classroom. You may think it overcomplicates the system to create a table for something so simple as classroom, but I promise you, if we put in the extra effort to design the structure properly, it will save time and avoid frustration for the life of this database. I look at creating classroom, or just room, as an entity, as another victory in the fight against inconsistent and redundant data entry. Store it once, reference it many times, right? There's another benefit too. If we ever rename a room in our school, we will only have to edit its name in one record of the database. And because we referred to that room in the related tables by its ID number, the name change will not break any relationships. And the new name will appear in place of the old name in all screens and reports. We'll want each room to have a descriptive title like Room A or Room 11, and the capacity or number of students a room can accommodate would be appropriate here. That takes care of classroom, and we're almost done. Grade, like room, is an attribute of class, but since we may have many classes of the same grade, we do not want to store the grade name over and over, so we will put it in its own table with fields for ID and title. Now that we've addressed all the nouns we found in the process description, we are well on our way to a complete entity relationship diagram, or ERD, which we will build in part 2 of this series. See you there.